Very good morning, all. Today we are going to discuss about some important rules in the unit of electricity and magnetism, as well as important phenomena in the geometrical optics. So I'm just going to take two different units. I'm just going to show you a glimpse on some important topics on the unit of electricity and magnetism, as well as in the unit of geometric optics. So to start with, the first one is all about the Ampere swimming rule. So here, the name itself gives a meaning, which is it's a swimming rule. So you could see the figure very well displayed here. Here, according to this rule, if a swimmer swims in a direction of current facing a magnetic needle, then the north pole of the magnetic field deflect towards his left hand and the south pole towards his right hand. So you please imagine a swimmer swimming in a pool or a lake. So now the magnetic needle just below the swimmer. So this magnetic needle, the north pole of the needle deflect towards the left hand and the south pole deflect towards the right hand, when if the swimmer swims in a direction of current facing a magnetic needle. So this gives a relation between the current and the magnetic field. So the next important rule is Maxwell's corkscrew rule. So here, if a right-handed screw is turned to advance along the conductor in the direction of current, the direction of rotation of the screw gives the direction of the lines of force. So here you see the direction of the current. You please imagine yourself a right-handed screw. So when a screw is turned to advance along a conductor, that direction indicates the direction of the current. The direction of rotation of the screw gives the direction of the lines of force. So this is all about the Maxwell's corkscrew rule. So this gives information about the direction of the magnetic lines of force as well as the direction of the current. So the next important rule is right hand clasp rule. So you please imagine yourself clasping a conductor in the right hand. So when you clasp a conductor, automatically your four fingers except the thumb finger, it will bend. So the thumb which doesn't bend, which stands straight, it indicates the direction of the current, whereas the direction of the bend of the rest of the fingers gives the direction of the magnetic lines of force. So this is all about the right hand clasp rule. So far we have discussed Ampere's swimming rule, Maxwell's corkscrew rule, and the right hand clasp rule. So in addition to this, I'm just going to show a glimpse on some important properties of light, which is in the fifth unit. Some of the important properties has been listed here. So the first one is a refraction of light. So here you could see two different colors. So the colors indicate two different medium. So the incident ray, the red line indicates the incident ray. So the incident ray, when it enters into the next medium, when the medium varies, there is a bending. There is a bending in the light ray. So this bending of light is said to be the refraction of light. So when a light ray travels from one medium to another medium, so there is a change in its path. So this bending of light ray is said to be the refraction of light. So the next important phenomena is a reflection of light. So here the light which is named as incoming light, here it is here you please see the yellow line. So this incoming light, after it incident on a interface, it just reflect back, it just bounce back and returns back to its own medium. So this property of bouncing back of light is said to be the reflection. So there is a vast difference between a refraction as well as reflection. So refraction is bending of light ray, and light travels from one medium to another medium, whereas here in the case of reflection, light actually makes a transition. It actually bounces back to its original medium. So this is said to be the refraction. The next thing is diffraction. As you could see in the figure, diffraction of light is nothing but the bending of light rays around the corners or the edges. So bending of light rays around the corners or the edges is said to be the diffraction. So far we have discussed three different characteristics of light, which is reflection, refraction, diffraction. So the next one is dispersion. So the name disperse, it indicates that the colors are going to get dispersed. So what happens? What it actually means dispersion? So when a white light is incident on a prism, it will have three phases. So the prism, including the bottom, it will have four phases. That doesn't matter. So the prism, when a white light passes through a prism, the white light will get dispersed into seven different colors. So it is very well known. It is our GR colors: violet, indigo, blue, green, yellow, orange, and red. So this phenomenon is said to be dispersion. So we are going to send only a single white light, but this white light is dispersed into various colors. So this phenomenon is said to be dispersion. So the next thing is total internal reflection. So here three figures have been given. So the first figure, you see the incident ray. So when a light incident on a medium, it undergoes refraction, as I already mentioned. When the light enters into the next medium, there will be a bending of light, obviously. So that is all about the first figure. Coming to the second figure. So what happens if I change the angle of the incident ray? So if the angle of the incident ray is changed, so or increased, automatically the refracted ray is also, the angle of refraction is also increasing. So it just slowly grazes the surface of the interface. So when it comes to the third figure, increasing the angle of the incident ray further, the rays completely fall into its own medium. So this phenomenon is said to be total internal reflection. So so far we have discussed three important rules regarding electricity and magnetism, and five different phenomena regarding the geometrical optics. So all these questions are some important 2 mark questions. So you please kindly take a note of it, and you please study well. So the next important topic is refraction through a prism. So I think we can discuss a next slide later. So thank you so much.